Today's lesson is Rady Day 4, which is nonlinear inequalities. What does the word inequality mean? Inequalities mean instead of having one answer, you have a whole bunch of answers because x doesn't equal 6, x might be less than 6. So anything less than. So inequalities are these. Right? This is less than or equal to. This is greater than or equal to. The important part for you guys to remember, okay, think about the end game. We're going to get everything equal to 0, right? If you have an equation that's not equal to 0, you're going to make it equal to 0. So if we're saying less than 0, that means a negative number, and that tells you you're in the bottom of a fraction. If we're saying greater than 0, I want you to think, oh, that means positive number, so we're in the top. This is all about graphing, right? And when you graph, right, these are positive numbers, these are negative numbers. So if we're less than 0, your graph is down here. If you're greater than 0, you're up there. That can be a huge, huge help because this is pre-calculus. A lot of you are going to calculus. We're going to start off with limits, and limits are relying on the fact that you know where your ends are. This is the unit that teaches you where your ends are. So it's a big, big deal, right? Okay. So let's look at this one. How would you solve this? You would factor first, right? So let's factor. Because this says less than, you are interested in negative answers, right? So the first thing you got to do is factor. Then you're going to place it on a sign chart. And we've been doing this with your Rady. And now you're going to plug a number in. When you're in a hurry, a student taking a test or anything like that, what's the easiest number to plug in between a negative and a positive? 0. So if you plug a 0 here, 0 plus 5, and the 0 would be in this area because it's between -5 and 1. 0 plus 5 is positive. 0 minus 1 is negative. And what's the outcome if you multiply a positive times a negative? Negative. Now, he who does not understand his math will have to plug 2 more points in and figure it out. He who understands already knows what the other signs are. What are the other signs? Well, is either of these factors, are either of those factors squared? They're to the first power, so what happens to our signs? They alternate. So if this is negative, this is positive. If this is negative, this is positive. Remember tangent and togetherness. Tangent occurs if x plus 5 was squared, then we would have the same sign on either side. So if you understand that, you only have to plug 1 point in. If you don't get that, then you always have to plug all the points in. Now, we are accepting negative answers right now. So we want this one. So there's our answer, right? So we are. Now, why is this brackets? Because it's got the equal sign. If you have just a less than, you have parentheses. If you have a greater than, or sorry, if you have an equal sign with it, you're brackets. So this would give you parentheses. That would have given you brackets, right? Now we'll talk about in a minute whether it came from the bottom and we have to have a parenthesis no matter what, right? So when you do a sign chart, now this one was easy, it was a polynomial, but we're really going to be interested in rational functions. Rational means there's a fraction, so there's a top and a bottom. So for a rational function, what numbers go on your sign chart? The x-intercepts, or the top, and the vertical asymptote or the bottom. So if you are lucky enough to have a fraction, you got to check whatever zeroes out your top and your bottom. That's what you're looking for, those critical points. Other thing I'm going to show you one other thing to look for that can make these very easy. So let's do another one. We were nice here. We factored it for you. So what numbers are going to go in your sign chart? -2 and 3. Again, I've got a negative and a positive, which means I can plug 0 in. So if I plug 0 plus 2, I get a positive. If I plug 0 minus 3, I get a negative. And what's the outcome with a positive and a negative? Negative, right? And positive, and positive. Now this one says x is less than 0. So I want negative answers. I'm interested in this area right here. So it's, but I don't have an equal sign. So it's just going to be -2 to 3. This is using a sign chart instead of graphing. But let me ask you a question. What does a parabola look like? This has a positive leading coefficient. So if I were to think about the sketch, wouldn't it just look like this? So I can already see this is below, this is above. So if I have a parabola, because I know what a parabola looks like, I don't have to do a sign chart because I already know it looks like this. And if it were negative, it would be upside down, and then I'd know the middle would be positive. So the more you think about your parent functions and what the characteristics are, the less arithmetic you have to do because you understand what the graph looks like. So y'all take a second and do this one. I'm going to pause the recording and give you time. Okay, so I'm going to have a -5, a -1, and a 4. And these must go in order, right? Number line order. Now, here I have a negative and a positive, so that's my favorite one to choose because I could plug in 0, right? So if we plug in 0, well, this one I don't have to worry about, and I want you to think about something. When you see x plus 5 squared, when you see a factor squared, what does that tell you about the factor? It's always what sign? It's always positive. So do we even have to ever plug anything into something squared? No, because it can't change the outcome. Saves you a little bit of time. So here I have 0 minus 4, which would be negative, and 0 plus 1, which would be positive. So this outcome is negative. Now, is x, here's the 4, is x minus 4 squared? No, so signs will alternate. What's the sign over here? Positive. Is the -1 squared? Is the x plus 1 squared? This one? No. So negative, then what? Positive. It's not squared, so they alternate. Now, x plus 5, is that squared? Yes. So around that 5, what happens with your sign? It stays the same. Do you see how much easier that is than trying to plug in 4 different numbers? Signs either alternate or they stay the same. They stay the same when this is raised to the even power. Much better than plugging a bunch of numbers in, right? Make yourself a note. Same sign, both sides of 5 because x plus 5 is squared. You kind of need to write it out. If you just write that, you won't know what you mean, right? I think we should even put another note here. Signs alternate because factors not, it's actually raised to an even power, but I'm going to put not squared because that's what we're usually dealing with. And I'm going to put here even power because if it was the 4th power or the 6th, that would have the same end result as a square, right? Do you see, does everyone get how we decide if we should alternate signs or retain the sign? That's a huge deal, because if you had to do 5 of these on a test, you're plugging in 5 numbers to find 1 on each one instead of plugging in 25 numbers, right? We don't want to work that hard. Okay, now let me let you do this one. That one isn't factored, so I'm going to give you a minute and you factor it. All right, so we're gonna, let me go back to this one for a second because we forgot to write the answer down, or I forgot. This says less than 0, so I want what kind of answers? Negative. So I'm gonna color in my negative. Oh, I only have 1 spot. So that is gonna be from where? It's got an equal sign, so that's gonna be -1 to 4. Now I wanna show you something else also. Does it match what you already know about graphing, what you learned the last unit? Well, this, all your x's are positive, right? So what does that tell you about the right side? Right side goes up. So if I did the right side up and I cross at my intercept, going up, and then here I bounce. So if you wanted a sketch of that, this is what we learned in our polynomial unit. Very good to keep that going, right? We don't want to forget that. Okay, we look at this one. And what did you guys get for factors? Let's see, that's x minus 5, x plus 3, greater than or equal to 0. Since this is greater than, we want positive, right? Without even doing this, do you know which part is positive? You know it's a parabola, right? So the ends are going to be your positive part, aren't they? If you know that, you can do parabolas without worrying about it, but we're going to worry about it because we want to practice sign charts. We need those for calculus because calculus is asking you which way your endpoints, right? Again, I'm going to plug in a 0 because it's between the negative and the positive. What happens when you plug a 0 in? You get what? A negative times a positive, which is a negative. Signs alternate. So I got that done. Why do signs alternate? Because nobody's squared, right? None of your factors are squared. This is x squared, but that's not a factor. So that doesn't matter. So I want positives. That's the part I want. I want the positive ones. So this is going to be negative infinity to -3 and 5 to infinity. Infinity is always a parenthesis because we don't get to infinity. It's not. All right. Everybody comfortable with the system we're using? Because now we got to go to this units. These are last units type equations. Now we got to bring in our rational. Not hard. You'll be fine. So first of all, I'm going to put my numbers on there. What numbers go on your line? Well, whatever 0 is the top, whatever 0 is the bottom. So that's going to be what? -2 and 4. Again, we got lucky enough to have a negative, right? A negative positive, so 0 is easy. So 0 plus 2 is a positive. The bottom always has what sign? The bottom is squared, so do you even have to think about it? The bottom's not relevant. It can't change your outcome, so we're only interested in the top. So this is positive, right? Now, is the x plus 2 squared? No, so what's this sign over here? Negative, because they alternate. The 4 came from here. Is this squared? Yes, so do the signs alternate? No. So there we go. Now we want positive answers. So I want this and I want this. But we need to discuss something now. The 2 is a good number because I can have a 0 in the top. What about the 4? Can I actually use that 4? You can't use the 4. So even though this says equal to, what symbol do you need with your 4? A parenthesis, because a bracket says you can use it. It's inclusive. So we have to know that we can get really close to 4, like 3.9999999, but we can't actually plug a 4 in because it would zero out the denominator. So what is our answer going to be? -2 to 4, and we have to put a parenthesis, right? And then 4 to infinity. These parentheses, because 4 came from denominator, or if you want the English term, bottom, because we must never, ever create a 0 in the denominator. True? True. Now let's practice graphing for a second and see if you know what this looks like. So we would have an x-intercept right there, and we would cross the x-axis right there because it came from the top. And what would the 4 be? It'd be an asymptote, right? So what does this look like? Well, because it's negative over here, positive here, and we know if the bottom is squared, they're together. So you can already imagine what that looks like, okay? I just like to show you how what we're doing today, you could get the same outcome by graphing. Most of the time, if you just need to know where it's positive or negative, it's easier to do a sign chart than to do a graph. As you get faster and faster at graphing, you can picture these in your mind and you can be really quick with it, right? Isn't that cool? Oh, admit it, that's so cool. Okay, one more. So I'm going to pause for a second. And well, let me factor this with you. How do you factor this? What is that? X minus 6 and x plus 1 over, right? Now I want to point something out real quick. If you have this versus this, right? I want to make sure you notice the difference between an x and a number. If you had this, you would have zeros. Let me say 0 equals actually instead of y. X equals 0 and 3, correct? Because there's an x outside the parentheses. But if you just have a number, how many zeros do you have? Just 1, correct? The number 2. If you have a coefficient by itself, it does not create a 0, right? We get so used to seeing an x out there and making it a 0. If we have a coefficient, we try to make that 0. So just make a distinction between these two in your mind. That's just a factoring thing, but sometimes we forget that. Okay, so this one, of course, will have a 0 out there. So let me pause you for a second and let you try this one. All right, let's try this out. So since I have 4 factors, I know I have 4 little spots, right? Over here, I have 3 factors. I have 3 spots. So what is going to go on here? What's my lowest? -1. Then what? 0, 3, and 6. How many? Now, are any of these factors squared? No. So my signs are going to alternate, correct? So I only have to find one. What number do you want to plug in? I would probably plug in a 1. Right? 1 would be between 0 and 3. So I would find this sign, right? If you plug a 1 in, what do you get? 1 minus 6 is negative. 1 plus 1 is positive. Plug a 1 in here, it's positive. 1 minus 3 is negative. What do 2 negative signs give you? Positive, right? An even number of negative signs gives you a positive outcome. We don't worry about positive signs. So now what are your signs going to be? They're going to alternate. Why are they alternate? Write it down one more time. Signs alternate because no factor is squared. And I'm going to put even power because we could have the fourth also. All right. Do I want positives or negatives in this case? We want the positive one. So just to keep my eye from wandering to the wrong interval, I'm going to do that. Now I'm going to write my answer, right? That, and there's no equal sign. So everybody will have a parentheses. So, or parenthesis, I should say, negative infinity to negative 1, 0 to 3, 6 to infinity. I write too big now. I've interfered with the next guy. That's okay. Any question about this? Is it good? All right. We got one more to do. Here we go. What are my zeros here? Well, that's a negative, -5, -3, and 3. Is any factor squared? No. That's not squared, that's not squared, that's not squared. This x squared minus 9 is not a factor squared because x is not a factor, x is a term. You have to factor it out, right? So I would try 0 because it's between the negative and positive. And if I plug a 0 in, what outcome am I going to get? Positive, positive, negative. So that's negative. Do my signs alternate? Are any of these raised to an even power? No. So my signs alternate. Don't you like knowing that and not plugging in a whole bunch of numbers? I do. And we want negatives this time, right? We want negatives. Now, it's got an equal sign. So if it came from the top, it's okay. Negative infinity to -5. And that 5 is going to have a bracket. But can the -3s have a bracket? Can they? They cannot, because they came from the bottom. We're not allowed to zero that out, even though there's an equal. So we must parentheses. Okay, let's sum this up real quick. We use parentheses when there's no equal sign or when the number comes from the bottom. And let's write the word denominator so we know it. Right? Use brackets when there is an equal sign and the number comes from the top or the numerator. Right? Because we're fancy, we like to write fancy words. So let's see if we can do a real problem. Like, who would use this? Well, let's look. From November 2003 till March 2004. So since they gave me those months, I'm going to write them down. That's November, December, January, February, March, right? So from November till March, Walmart stock was worth that much money at any given time, right? They have an equation where P denotes the price of the stock in dollars and T corresponds to months. November is represented by T = 1. Right? So this would be T = 2, 3, 4, 5, right? We have to pick what our first starting month is. December's 2, January's 3. During what months was the stock at least $54? So if this is our equation, and it says at least $54, does that mean equal to 54, less than or equal to 54, or greater than or equal to 54? At least. That means it can be 54, but it could be bigger, right? Can't be less. Right? So make sure you got that set up. Now we haven't done one with a number on one side. We need it to be a 0. So what should we do? Subtract 54 from both sides, right? So what do we have? What's 70 minus 54? That's 16, right? We like that a lot better. That looks a lot easier. Now, could you simplify this equation anymore? Yeah, you could. So we can divide out a 2. We just have to divide everyone, right? So now we have t squared minus 6t plus 8 is greater than or equal to 0. And now we will, now that we have a 0 in there, we can follow today's rules. And we're going to say t, what is that, minus 2, t minus 4. So t equals 2 and 4. So now we'll do a little number line. Put on a 2, put on a 4. So what number would you like to plug in? 0. 0 is good, right? Now let me ask you this though. Does this thing go to 0? Do we really have an arrow there? When you're in a real world problem, okay, can we just stick arrows on both sides? Not really, because this started with November. So I really kind of need to block it off right there. 1 is not part of this, but I need to know it doesn't go on forever. When we do real world problems and we try to model things like stock prices with an equation, that equation is not good forever. It may be for a block of time. Are you guessing that Walmart has a different profit equation in the fall than they do in the summer or the spring? Yes. What happens in the fall? Christmas rolls around. What happens to Walmart during the Christmas season? People are spending money, right? There are certain times of the year. If you were going to Leslie's Pools, do you think they sell as much stuff in January as they do in July? No, right? So any equation you get that's real life model, that is a real life model, we need to make sure we know when it begins and ends, because equations that are talking about prices or sales, those don't go on forever. They change over time, right? So this starts at 1. I would plug in a 3 because I want to stay in between the months they gave me, right? Because it only goes to March, so it only goes to here. This equation, as far as we know, is only good for these few months. It might go longer. My prediction is that the equation changes after that, right? Sales change. So if you plug a 3 in, 3 minus 2 is positive. 3 minus 4 is negative, so this is negative. That means this is positive, this is positive. So we can use the 2 and the 4 because those would 0, that would be at least. So what's the only month that's no good? What's the only bad number on this? Well, what number would be between 2 and 4? 3. So month 3, right? Month 3 is a no. Sales are down. We wouldn't have decimals on this because those numbers represent months. It's either January or February, right? We don't say January and a half. So months 1 and 2 are good. Those are positive, or 2 is 0. And we said 0 was okay. And February and March. So if it said during what months was the stock at least 54, we would say November, December, February, and March. Whoops. Were at least $54. Or if you were writing out a sentence. Does that make sense on that? I like to point it out because we get used to just equations where we have arrows. When we get into real world problems, we have to read it and say, I might have a beginning and I might have an end. This equation might not be useful forever, right? There may be a different equation when you get into Walmart sales stock prices in July, right? Okay, that's it. Now we have to go to Unit 10, Day 4 math line.